welcome to the fourth session of 16th module on blockchain and smart grid analytics. In this session, we'll talk about open source Hyperledger project. We'll talk about various projects on the Hyperledger, particularly Hyperledger Fabric and Hyperledger Composer. We'll also talk about the blockchain service made available on IBM Cloud and how you can make use of it. Hyperledger is a project under Linux Foundation. It's an open source project which basically got conceptualized sometime around December 2015. So it's pretty nascent for that matter, right? And it's a collaboration effort which was basically created to advance cross-industry blockchain technologies, particularly for business, right? So it is open source, it's open standard, it has an open governance model, which enables it to be fit for enterprise consumption. Okay. And since 2016, over a course of last, almost like 2 years, we have now scaled to 270 member organizations. Now, if you see on the right-hand side, you'll find the who's who of the industry right there, right? Right from Accenture to Airbus to MX to Intel to JP Morgan to IBM, SAP, you'll find all of them as premier partners to the Hyperledger project, right? And besides that, there are so many other partners, including academia associates. So this program is even open to academia, right? So any academician who has interest in blockchain can actually join Hyperledger community, can contribute to the code, can contribute to the project in whatever way they want to. Now, Hyperledger Fabric basically is implementation of blockchain technology, and it has emphasis on ledger, smart contract, consensus, confidentiality, resiliency, and scalability, which are the needs for any enterprise to adopt to blockchain technology. IBM is just one of the many contributing organizations, and the first active release of Hyperledger Fabric was in 2017, and since then we are seeing version 1.2, which has released recently in July 2018. Now, what is actually a fabric, right? So, as we talked, the project is a collaborative effort to create advanced cross-industry blockchain technology. Now, Fabric is particularly from our implementation of blockchain technology, which is intended for foundation of developing blockchain applications, right? The key technical features are: one, it has a shared ledger and it has smart contract implementation, which is called chain code here. It has privacy and permissioning mechanism through membership services, and it has a very modular architecture, and it has flexible hosting options, which make it really ideal for enterprises to adopt, right? So since the first release, which got released in July 2017, we have now version 1.2, which recently released in July 2018, right? And it has contributions from so many engineers from different organizations. Now, this is the roadmap for Hyperledger to go at it, right? We are expecting a release version 1.3 of the Fabric sometime soon. Let's talk about the Fabric architecture, right? So right now we're talking about Fabric v1 architecture, right? So if you see there are a couple of components there. There's a client application, there is a SDK, there is an external certificate authority, there is a membership service, there are something called a peer there, then there is an ordering service and all. Let's try and get to each of them in some detail there, right? So in a version 1.v1 architecture, the peers are primarily of two types, right? So we have a endorsing peer, we have a committing peer, right? Or a peer, as we say. Now, an endorsing peer is a specialized peer which basically endorses transactions by receiving a transaction proposal, right? So we'll just detail it in a while. I'm just giving a brief overview right now. The peer is somebody who basically maintains the ledgers and the estate. So they are responsible for committing the transactions and also may hold the smart contract or the chain code for that matter. Let's talk about the Fabric peer. Now, each peer connects to one or more channels, right? Now, channel is nothing but a communication mechanism between multiple peers. And the peer maintains maybe one ledger or more than one ledger. If it's connected to more than one channels, so per channel it will have one ledger, right? It also manages the chain code, which is basically installed on that peer, right? It manages the runtime Docker containers for that chain code, which is instantiated on top of that particular peer, right? It has a membership service provider, a local MSP, which provides for the crypto material, right? And all the other events. It emits the events to the client application. Now, what is a client application, as we saw in the previous chart there, right? So a client application uses a Fabric SDK for connecting to the channel to one or more peers, number one. Number two, it connects over the channels to one or more orderer nodes, right? and it basically receives the events from various peers it's connected to. It also has a local MSP, which basically provides the crypto material. Now, the client can be written either in a Node.js or a Go or a Java or a, so these are a couple of SDKs which are already available for writing the code. Similarly, the Fabric CA is basically the certificate authority is basically a key functionality in the V.1 architecture. What it basically provides is, number one, clustering for high availability characteristics, right? It provides for LDAP for user authentication. It also supports HSM for security. And of course, it can be configured as an intermediate certificate authority as well. So if you see there, it basically provides for those enroll certificates, T certs, E certs, for the transactions to happen between multiple peers there. Now, how does an application interact with the ledger? Let's try and understand this. So a blockchain developer writes or creates an application using a SDK, right? That's a client application. This client application talks to, submits a particular request to a smart contract, right? Now, what happens? This smart contract basically talks to the two, you can say, databases which are available in a blockchain-based system. One is called the world state, and the other is called the blockchain, right? Now, blockchain is nothing, as we talked earlier, but chain of blocks of information which are tied to each other using the hashes, right? And normally a blockchain has historical data recorded, right? Whereas a world state has the current state of a certain asset, right? So a smart contract has all those get, put, delete, or whatever it's basically in the world state, wherever all the other, the historical transactions goes into the blockchain to get recorded. And once any of these things is happening, it emits an event, which the event basically goes back to the client application and the other relevant nodes for that matter. Uh, let's talk about a fabric ledger, which is basically maintained by each peer and includes the blockchain and the world state. So these are the two DBs which are maintained in a blockchain, the ledger and the world state. Now, a separate ledger is maintained for each channel that the peer joins, right? The transactions are nothing but read write sets which are written to the blockchain. Channel configuration is also basically written on the blockchain, right? A world state can be either a levels DB or a couch DB, either of the two depending upon how you want to use it. If you want to have a simple key value pair store, then level DB is a good option. If you want to have a document store which needs, and you want to run some complex queries on that, then CouchDB is a good option, right? The smart contract decides what is basically written to the world state, right? As we already talked about, if you see there are two things. One is the blockchain of the ledger, and the other is the world state there. Let's quickly, talk about the Hyperledger Fabric, how the consensus thing happened. The consensus is achieved using a particular transaction flow, right? The client application sends an application to or a request to the endorser. The endorser endorses it in a certain way. We'll see that in detail in next slides, right? It is basically sent to orderer, and then the validation process happens. Finally, it gets a commit process. So let's quickly talk about how the flow happens in this particular architecture, right? So let's assume there's a client application, and let's see there's a blockchain network which has a couple of peers, E0, E1, E2, and P3, P2, P3, P4. Depending upon what role do they basically do in this network, whether they're a endorser node, whatever it's a committer or whatsoever it is, this particular slide is color coded, and even the smart contract running on these are color coded. Let's try to understand the figure first, right? What this Hyperledger Fabric network is all about. So there are three nodes, E0, E1, and E2, which are doing the role of an endorser, and they are running a smart contract which is labeled as A, B. If you see, there are two blocks A and B running on E0, E1, and E2. That means the endorsement contract is basically running on E0, E1, and E2. Similarly, there is another node which is basically the P3 and P4, right? So P3 and P4, again, they are running the smart contract, but then you see there is a smart contract for A, but then there is a different altogether smart contract for a different business process, which is labeled as D here, right? For endorsement policy, the E0, E1, and E2 must sign whatever the client SDK is submitting as a transaction, as a request, right? P3 and P4 are currently not the part of the policy, right? So client application submits a transaction proposal to the smart contract A, which is running on E0, E1, and E2, right? Once this is there, once this happens, the endorser, that is E0, E1, and E2, endorses each of these proposed transactions, right? Now, so far, none of the transactions will be updated in the ledger. Nothing is going to be written in the ledger, right? It is all being simulated in the endorser node, right? And what will happen is the execution will capture the set of read and write sets, whatever, the RW sets, right? Which is now going to be flowing in the fabric further, right? Now, these transactions are basically signed and encrypted, after the whatever the endorser is doing, and these are actually fed back to the client application, right? All these endorsements, right? So what is that? These are RW certificates along with the signed of each endorser, right? This is basically fed into back to the client application, the SDK. Once the responses are received from the endorsers, these responses are basically channeled to the ordering service. You see that O4 ordering service node is basically a cluster of ordering service, where all these transactions are fed to. Now, what will happen is the ordering service happens across the fabric in parallel with transactions, submitted in the other applications. Now, and there are so many other, nodes which may be actually feeding in the transactions to the ordering service. So that's the reason we're talking about ordering cluster there, right? What will happen is once it's just like a message queue, right? So you have multiple requests coming in and they're being sequenced out to orderer. Now, once the orderer sequences them out and they are followed to the committing peer, in our case P3 and P4 are the ones. Now, these transactions are basically collected in blocks, right? In certain blocks, and they are actually given to the committer peers. Now, what happens is, based upon the different ordering algorithm, it can be used. So one is the solo or the single node, which is primarily used for development only. But then for production, we propose something called as Kafka, which is a message queue and which is crash fault tolerance, right? So which is actually the way enterprises go and adopt blockchain-based solutions. So what happens is the committing peers now validate the transactions being submitted to them by the orderer. And what do? They basically validate these against the endorsement policies. Okay. And they also validate the read-write sets and they see whether they're actually still valid for the current bird state. Now, what is this point about? For a certain transaction X, which has the value X is equal to 3 at any point in time when the transaction was initiated, and the client application is proposing to change the value of X is equal to 3 to X is equal to 5, right? Now, the point is, during the process of this ordering, endorsement and all, when this actually lands with the committing peer, the committing peer is actually going to check whether the value X is equal to 3 and the proposed value X is equal to 5, which is being now tried to be verified, is really right. There should not be a case that the value of X is already changed in the process in some way, and or maybe try to change by some other node there. That is what we term as a double spend there, right? Now, once the transactions are validated, these validated transactions are applied to the world state and retained on the ledger, right? You know what? In this particular scenario, the invalid transactions are also retained in the ledger, right? But then they're not updated on the world state. Now, what happens is, once this updation has happened, the committing peer notifies the application, so that they can update the ledger in real time. That's what we talked about, right? So when there is a transaction which succeeds, the blocks are added to the ledger, right? So the application is basically updated about and notified about that the peer to which they are connected, so that information flows back from the committer to back to the peer, the application, the client application. Okay, so before I go on to this slide, so we talked about Hyperledger Fabric. This is one of the projects under Hyperledger open source project under the Linux Foundation, right? There's another project under Hyperledger which is termed as Hyperledger Composer, which is basically aimed at accelerating time to value. So there, so from a business analyst point of view, right, if you want to immediately show a value to a particular client about how you can make use of blockchain-based solutions, Composer provides a high level of abstraction for business networks, right? The emphasis here on creating some sort of solution which can be quickly created and which can show the value that blockchain solutions provide, right? You can model your business networks with very easily, quickly, and you can test them, you can expose them via APIs. These applications invoke API transactions to interact with the business network. They can integrate with the existing system of records using loopback or REST APIs, right? And again, the composer is fully open and it's part of the Linux Foundation Hyperledger project, right? In case you want to try this, you can actually go to the URL mentioned there, composer-playground.mybluemix.net. This is an approach wherein, on the cloud it is made available to you. You do not need to install any component on the local machine. You can simply go ahead and you can play with the composer in this way. uh, what are the benefits of using a composer, right? One, it increases the understanding of blockchain as a technology, right? So simply from a blockchain concept to a blockchain as a solution, it really increases that understanding composer. It saves a considerable amount of time because you can actually create blockchain solutions very quickly and very cheaply. Since it provides you for the testing, and you can redesign it, so therefore it reduces a lot of risk there. And it has very high flexibility because that abstraction allows it very easy to iterate. You can do multiple iterations quickly, right? And Composer basically is familiar. It has so many open development toolkit, which includes basically loopback, swagger, npm, javascript. So many of them are basically available today. So in order to get started, there are a few links. There is some elaborate support available on Hyperledger Composer. You can go to hyperledger.github.io/composer, where there is adequate documentation available on how to use Composer. Alternatively, you can simply go to the composer-playground.pybluebix.net and get started using, doing some form of blockchain solutions. There are a lot of sample networks which are made available, which can be readily used and start playing with, right? So Composer are easy way of defining, testing, and deploying business networks. They basically create domain APIs and sample applications, and then of course they can integrate with existing system of records, as we already talked about. Let's talk about a more complete blockchain platform which provides for almost everything that a enterprise application needs, right? So IBM provides for blockchain service on top of its cloud, and IBM Cloud. So IBM Cloud provides blockchain service, which is a fully integrated enterprise ready blockchain platform, which is designed to accelerate the development and the governance, of course, the operation of a multi-institution business network. Now, when I say multi-institution, I mean that you can have multiple parties joining in the business network at different points in time. So you can provision that, right? It provides you with a lot of developer tools that can make use of Hyperledger Fabric SDK to quickly build the applications, right? Now, the underlying technology is of course Hyperledger Fabric, which is powering IBM blockchain there, right? So Hyperledger Fabric also provides the ledger, which is managed through a set of intuitive operational tools, right? And so in case you want to access, there is a URL at the bottom, console.bluemix.net/catalog/services/blockchain, where you can go and you can lay your hands on. So currently this service comes in two flavors. One is there's a free starter plan available, and then again there is an enterprise plan available for somebody who wants to get it started and understand the blockchain, how this is all about. They can instantiate a service there, and they can start playing with the starter plan, and then once people are more serious towards adoption, they can move to the enterprise plan of the service. With this, we conclude this session for this module. In the subsequent section, we'll talk about a couple of code patterns, how they can be made use of, how blockchain is being used for decentralized energy, and we'll also try to use Hyperledger Composer through some hands-on exercises that how they can be used in terms of creating blockchain solutions in very quick, very less time. Yeah, see you. Thank you.